Okay, hello everyone. So let's continue to the rest of the questions of chemical bonding and molecular structure. Okay, so let's start. We have question number 32. Which one of the following molecules are expected to exhibit diamagnetic behavior? Options are N2, O2, S2, or C2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be A and D. So C2 has 12 electrons in it, and we can arrange the 12 electrons in the molecular orbital and write the orbital configuration in this way. And N2 has 14 electron in it, and we can write the 14 electron orbital configuration in this manner. As all the electrons are paired in C2 and N2, you can see no unpaired electrons are present. Thus, both C2 and N2 are diamagnetic. Hence, option A and D both are correct. Moving on to the next question, that is question number 33. Which of the following statements is or are correct? Options are: in the formation of dioxygen from oxygen atoms, 10 molecular orbitals will be formed. All the molecular orbitals in the dioxygen will be completely filled. Total number of bonding molecular orbitals will not be same as total number of anti-bonding orbitals in dioxygen. Number of filled bonding orbitals will be same as number of filled anti-bonding orbitals. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So in the formation of dioxygen from oxygen atoms, 10 molecular orbitals will be formed. You can see here that O2, and this is the molecular orbital configuration of O2. So we have 10 molecular orbitals which will form in the formation of dioxygen from oxygen. Hence option A is the correct answer. Moving on to next question, question number 34. So in accordance to molecular theory, options are O2 positive is diamagnetic and bond order is more than O2. O2 positive is diamagnetic and bond order is less than O2. O2 positive is paramagnetic and bond order is more than O2. O2 positive is paramagnetic and bond order is less than O2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option will be option C. O2 positive contains one unpaired electron, so it is paramagnetic and therefore it has bond order of 2.5. While O2 contains only two unpaired electrons, so it possesses bond order of 2. Hence option C will be the correct answer. Moving on to question number 35. The stability of the species Li2, Li2 minus and Li2 plus increases in the order of. Options are the most in Li2, then Li2 positive, then Li2 negative. Most in the Li2 positive, then Li2 negative, then Li2. Most in the Li2 positive, then Li2, then Li2 negative. Most in the Li2 negative, then Li2 positive, and then Li2. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. The stability of molecule is directly related to the bond order of the molecule. So in Li2, having 6 electrons, this will be the molecular orbital configuration of Li2. If we find out the bond order, it will be 4 minus 2, as 4 electrons are present in the orbital and 2 are present in the anti orbital. So 4 minus 2 divided by 2, which is coming out as 1. In the Li2 negative, 7 electrons are present. So this is the electronic configuration. And the bond order will be 2 plus 2, that is 4, minus 2 plus 1, that is 3. So 4 minus 3 will be 1. 1 divided by 2 will be 0.5. In the Li2 positive, 5 electrons are present, and this is the electronic configuration, orbital configuration of Li2 positive. And the bond order will be 2 plus 1, 3, minus 2. Only 2 electrons are present in anti-bonding. And then 3 minus 2 will be 1. 1 divided by 2 will be 0.5. As both Li2 negative and Li2 positive has 0.5 bond order, but Li2 negative is less stable because its valence electron is present in anti-orbital, you can see here. Hence, the stability order will be most in Li2, then Li2 positive, and then Li2 negative. So, option A will be the correct answer. Moving on to next question, that is question number 36. Which of the following pairs of molecules or ions are not likely to exist? Options are H2 positive, He2 2 negative, H2 negative or He2 2 negative, H2 2 positive or He2, He2 negative and He2 2 positive. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. Species having 0 or negative bond order do not exist. But H2 2 positive having 1 plus 1 minus 2, that is 0 electrons, having the configuration sigma 1 is 0. So bond order will also be 0. Hence, as since no electrons are present in anti-bonding or bonding orbital, so the bond order will be 0. And in the helium molecule, 4 electrons is present, having the configuration of sigma 1s2 and sigma star 1s2. Bond order will be electron in the bonding and then minus electron in the anti-bonding upon 2. That is 2 minus 2 divided by 2, which will be 0. So both the bond order of both the molecule will be 0. So the both H2 2 positive and He2 do not exist. Hence, option C is the correct answer. Moving on to next question. Question number 37. Orthonitrophenol is less soluble in water than para and metanitроphenols because options are orthonitrophenol is more steam volatile than those of meta and para isomers. Orthonitrophenol shows intramolecular hydrogen bonding. Orthonitrophenol shows intermolecular hydrogen bonding. Melting point of orthonitrophenol is lower than those of meta and para isomers. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. There is intramolecular hydrogen bonding in orthonitrophenol and thus solubility in water will be decreased. You can see here the structure of orthonitrophenol having the intramolecular hydrogen bonding present in it. Thus the solubility of the orthonitrophenol in the water will be decreased due to this intramolecular hydrogen bonding. Hence option B will be the correct answer. Moving on to the next question, question number 38. Consider the following compounds. First, 1,2-hydroxybenzene. Second, 1,3-hydroxybenzene. Third, 1,4-hydroxybenzene. And fourth, hydroxybenzene. The increasing order of their boiling points is. Options are most in fourth, then third, then second, then first. Most in third, then second, then first, then fourth. Most in third, then first, then second, then fourth. And most in third, then fourth, then second, then first. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. And you can see here the diagram of 1,4-dihydroxybenzene. And 1,4-dihydroxybenzene, an isomer of dihydroxybenzene, shows highest boiling point due to intermolecular hydrogen bonding, followed by meta and ortho isomer, which shows intramolecular hydrogen bonding. Hence, option B and the order present in the option B is correct one. Moving to the question number 39. We have given a table in which two columns are present. One is having reactions and other is having the energy change in kilojoule of that particular reaction. So based on the data provided, the value of electron gain enthalpy of fluorine would be, which is missing in this table. So we have to calculate the fluorine reaction gain, electron gain enthalpy. Options are minus 300 kilojoule mole inverse, minus 350 kilojoule mole inverse, minus 328 kilojoule mole inverse, or minus 228 kilojoule per mole. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. So from Born-Haber cycle, we can see that Q will be equal to S plus I plus D plus EA plus U minus 617, which is coming out as 1601 plus 520 plus 77 plus EA minus 1047. That is the sum of this whole energy change will be equal to Q. Here S is sublimation energy, I is ionization energy, D is dissociation energy, EA is electron gain enthalpy, U is lattice energy. And on interchanging the terms, the value of EA is coming out as 289 minus 617, that is minus 328 kilojoule per mole. Hence, option C is the correct answer. Moving on to the next question, question number 40. We have given a direction, that is, in the following question, a statement of assertion A followed by a statement of region R is given. Choose the correct answer out of the following choices. So assertion is the bond angles in molecules depend upon electronegativity of central atom, number of lone pairs, and odd electrons and multiplicity of bonds. Reason is NO2 and NO2 minus have angles 134 degree and 115 degree respectively. Options are both A and R are true, and R is the correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, but R is false. Both A and R are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. Reason is the correct explanation for the assertion, as the bond angle in molecules depend upon the electronegativity present in the atoms of that molecule or central atom, and the number of lone pairs or the odd electrons and the multiplicity of bonds. And the NO2 and NO2 minus, the structure is here, and we have the bond angles of 134 degree and 115 degree of them respectively. Right? Hence option A is the correct answer. Moving on to next question, question number 41. In this question, we have a statement assertion followed by a statement of region, and we have to choose the correct answer out of the following choices. The assertion is among the two OH bonds in H2O molecule, the energy required to break the first OH bond and the other OH bond is same. Reason: this is because the electronic environment around the oxygen is same even after breakage of one OH bond. Options are both A and R are true, and R is the correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, but R is false. Both A and R are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. The bond enthalpies of the two OH bond in water molecule are not equal. This is because electronic environment around the oxygen is not same after breakage of one OH bond in the H2O molecule. Hence option D, that is both assertion and region are false, is correct. Moving on to the next question, question number 42. Similarly, in this question, a statement of assertion followed by the statement of region A and R is given, and we have to choose the correct answer out of the following choices. Assertion is SF4 has a lone pair of electrons at equatorial position in preference to axial position in the overall trigonal bipyramidal geometry. Region is if lone pair of electrons is at equatorial position, repulsion will be minimum. Options are both A and R are true, and R is the correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, but R is false. Both A and R are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. Both assertion and region are correct given in the question, and region is the correct explanation of assertion. That is, in the SF4, a lone pair of electrons is present at the equatorial position in preference to axial position in the overall trigonal bipyramidal geometry. And region is that if lone pair of electron is at equatorial position, the repulsion will be minimum. So option A will be the correct answer. Moving on to the next question, question number 43. Similarly, here also we have a statement of assertion followed by the statement of region, that is R, and we have to choose the correct answer out of the following choices. Assertion is para-dimethoxybenzene is a polar molecule. Region, the two methoxy groups at para positions are located as like this. Options are both A and R are true, and R is correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, but R is false. Both A and R are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So para-dimethoxybenzene is a polar molecule which is given in the assertion due to unsymmetrical orientation of CH3 group as shown below in the given figure. So both assertion and region are correct, and region is the correct region for the given assertion. Hence option A will be the correct answer for this question. Okay. Thank you.